And here we are again with our last exception to the octet rule, the expanded octet. One important rule here, one thing to think about is that this only occurs with elements that are in the third period or below. And the reason for that is when we get to the third period, although phosphorus and sulfur do not have any electrons that are in the d orbital, it does exist. If you remember the Aufbau principle, the buildup principle with the arrows, 1s, 2s, 2p, all that stuff, that when we get to energy level 3, the d orbital starts to come into play, and that allows us to expand beyond 8 electrons. Essentially what we're talking about is compounds that have phosphorus, sulfur, selenium, bromine, or iodine as the central atom. It's going to be a little weird to think about bromine and iodine as a central atom, but it does occur. And so we're going to start by going over two compounds here, two relatively simple compounds. One is phosphorus pentahydride. We have pentahydride because there are 5 hydrogens here. We go about it in the same way. Let's start counting valence electrons. Phosphorus has 5 valence electrons, and each hydrogen has 1, that gives us 5, so we have a grand total of 10. Looking at this, again, we know hydrogen cannot go in the middle, so phosphorus is going to be our central atom. We're going to put phosphorus in the middle, and then we're going to start drawing single bonds to all the other atoms around it. And we get H, 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 and H. Looks like a very happy person doing a jumping jack like you're going to be after you understand this. So here we've used up all 10 of our electrons. Although this has more electrons than 8, that's okay because it is phosphorus, all right? If we go down to SF6, a similar situation is going to occur. We have 6 electrons with sulfur, and then we have 6 times 7 is 42 electrons from fluorine, and we get 48. So our grand total is 48. What goes in the middle? You guys know this, it's going to be sulfur, and we are going to make a compound that has 6 fluorines around that central atom. And now I'm going to fill the octet in for all the fluorines. This is going to take a minute. There we go. Now my arm's tired. So we have sulfur hexafluoride here. Sulfur has 12 electrons around itself, which is okay. Now if you'll notice one thing about these two, phosphorus is able to make 5 bonds and it has 5 valence electrons. So this one's kind of important here. Sulfur has 6 valence electrons and it has the ability to make 6 bonds, all right? So if we step back over here, phosphorus has the ability to make 5 bonds, sulfur 6, selenium 6. Now bromine gets a little strange. Bromine can make 1, 3, or 5 bonds. Iodine, same, 1, 3, or 5. And you'll see, well, actually, now that I think about it, I'm not going to put any labels on iodine because who likes labels? I don't. All right, so here's our expanded octet. We've done a couple examples. You're going to get more examples in class, and that's something that you're going to be able to figure out relatively quickly.